Hello everyone, my name is Matthew Bajaya, and today I'll be teaching you the advanced skills in calculating the volume of a cone. This is an important skill that you may already know, but you might not know as much as you think you do. That's why I'm here, and I'm going to help you in some of the more difficult questions of this topic in math. For my example, I would like to use a question that I came across during a math lesson in my own school. This question was quite difficult for many of the students, including myself, so I would like to clarify how to do this kind of question. The question went a little something like this. A cone is formed from a circle of radius 20 centimeters with a sector of 90 degrees cut out. If you don't know what a sector is, it is the part of a circle that is cut out. The rest of the circle is, well, still the circle. From this, a cone can be formed with a piece of paper often, which is where I'm going to get with the first part of this question. What is the slant height of the cone? I found this part of the question a bit hard because how are you going to find the radius of a cone that you're making out of the sector? So for this part, I'm going to show you it with a model to make it much easier on yourself. So we'll say that this black line here is the radius of our sector, and it's 20 centimeters in length. Now if I fold this sector into a cone like so, we'll see the black line has not changed yet. Therefore, our slant height of our cone is 20 centimeters, same as the radius. Now that that's been answered, we can move on to the next part of the question. What is the radius of the cone? To solve this question, we must first find the circumference of the base of the cone. Of course, we realize that this will not be the circumference of the original circle, because a part of it has been cut off as a sector. To find the circumference, we must calculate how much of the original circumference is in the cone's circumference. We must realize here that a circle has 360 degrees around it. We've taken out a 90-degree sector of this circle. Therefore, we must subtract 90 degrees from this total of 360 degrees. 360 degrees minus 90 degrees equals 270 degrees. To find how much of the circle's circumference we will be calculating then, we must divide 270 degrees by 360 degrees to find the percent, which will turn into a fraction for algebraic purposes. 270 degrees divided by 360 degrees equals 0.75. This is equal to 3 over 4, or 3/4. So, we'll be calculating 3/4 of the circumference of the original circle. For the other part of our equation that we'll be using to answer this part, we must find out how to calculate the base of the cone for its circumference. We know that the algebraic expression for calculating circumference is c equals pi times d, where c represents the circumference and d represents the diameter. Another thing that we know is that the diameter is equal to 2r, where r represents the radius. Therefore, the diameter can be replaced with 2r in the expression c equals pi d to get c equals pi 2r. We'll still get the same answer for this. Altogether, our expression would be 3/4 pi 2r. We can now replace r with radius 20 centimeters. We already know that pi will probably make this an extremely hard question, so we're going to leave it out and calculate that part out at the end. For now, we'll multiply 20 centimeters by 2 and then multiply that by 3/4, giving us the answer of 30 pi. We now know what the circumference of the cone is, so it's best that we divide it by the circumference of the cone. First, we'll show the algebraic expression that we showed last time, except without the 3/4, since we've already calculated that part. So it should read as circumference of cone equals 2 pi r. At this point, we already know that the circumference of the cone is 30 pi. So it now reads 30 pi equals 2 pi r. We must also remember that r here now represents the radius of the cone. So we can get that r out and leave it by itself by dividing that part by 2 pi. Of course, we can't divide one side of the equation without dividing the other side of the equation. So the equation would now read 30 pi over 2 pi equals 2 pi r over 2 pi. We do the division on both sides, crossing out any like terms. 2 pi and 2 pi are like, so we cross out those parts. And pi is also alike, so we cross out the pi in 30 pi. Then we do the rest of the division on that side, so we end up with 15 centimeters equals r. Now we must do the final part of this question. What is the volume of the cone to the nearest cubic centimeter? Of course, here we realize that we can't calculate the volume of the cone without knowing what its height is. Luckily for us, though, we already know what the slant height and the radius of the base is. So we can use the Pythagorean theorem to figure out what the height of this cone is. Because we basically are using a right angle triangle to figure this out, we'll calculate it using the formula h squared plus r squared equals s squared, where h represents the height, r represents the radius, and s represents the slant height. We'll substitute everything that we already know what its length is. So we already know that the length of the radius is 15 centimeters, and the length of the slant height is 20 centimeters. 15 squared is equal to 225 centimeters squared, and 20 squared is equal to 400 centimeters squared. Because we want to isolate the term h, we'll subtract 225 centimeters squared from the side that it has appeared on. Of course, we must subtract that from the other side as well. So now that leaves us with h squared is equal to 175 centimeters squared. Now we'll square root on both sides. So now we're left with h equals the square root of 175 centimeters squared. You'll notice I haven't taken away that square root symbol. Well, that's to make it easier on ourselves when calculating the volume of the cone. Now we go on to calculating the volume. We know that the algebraic equation for that would be V equals 1/3 pi r squared h, which would be volume equals 1/3 pi radius squared times height. Then we replace all the terms that we already know, which would be 15 centimeters in r, and the square root of 175 centimeters in h is placed. 15 squared is equal to 225 centimeters squared. Pi times 225 centimeters squared times the square root of 175 gets us the answer of 9,350.9 centimeters cubed. We divide that by 3 to get the answer of 3,116.9 centimeters cubed. On that note, this concludes my tutorial for the advanced calculations of the volume of a cone. Thank you for watching, and I hope you were able to learn a lot from it.